In this problem, we're asked to identify the horizontal and vertical asymptotes and the domain and range. I'm going to start by putting this function into the graphing calculator. Notice that I put parentheses around the numerator and parentheses around the denominator. And then I went ahead and I graphed it. Now I'm going to show you how we find out three key features here in this form, both horizontal, vertical, asymptotes, and also if there are any real roots. The denominator can be factored into x plus 3 and x minus 3. So I'm able to identify that I have a vertical asymptote at x equals -3 and x equals +3. Remember that asymptotes are invisible boundaries that will not be crossed. Occasionally we do have a horizontal asymptote that is touched, but our vertical asymptotes will never be crossed. And if a horizontal asymptote is crossed, it would be in the middle. It's not at the ends. It's not towards the limits going to the right and to the left. So if I go to 3 and I go up and down, I can almost make a dotted line right here on top of the graphing calculator, and at -3, you can see these are the vertical asymptotes. Again, our graph does not cross those. The horizontal asymptotes in this form, I can see that on top the highest degree is 2, on the bottom the highest degree is 2. When that's the case, I get to take the coefficient in front of both and divide. 2 divided by an invisible 1, 2 divided by an invisible 1 is 1. So the horizontal asymptote is y equals 1, which means it cuts through 1. And you can see here, I'll even give you a visual here. If we did the line y equals 1 as I go to the far right, 2 divided by 1 is 2. 2 divided by 1 is 2. And if I graph this, you can see that if this was the asymptote here, it gets closer and closer as it goes to the far right and to the far left. The other thing I'd like us to look at is in the top there is a variable. I can set the numerator equal to 0 and solve. So I'm going to start by dividing both sides by 2. 0 divided by 2 is 0, and the only number you can square and still get an answer of 0 is 0. What does that mean? That means at x equals 0, I have a real root. So the only real root in this entire function is at x equals 0. That is true. So those are important things to know. Now we're going to go through and we're going to identify these 4 components. So horizontal, don't just put 2, it's y equals 2. And vertical asymptote is x equals 3 and x equals -3. Now domain. Remember, domain is talking about going for the x values. So where does this occur in the graph? It occurs everywhere in the graph except there's no answer at 3 or at -3. And you can see if I plugged in 3, it will be blank. There is no number that it corresponds to. How do we write that down? This says the function comes from the very far left and goes to -3. Okay, it's going to jump over that asymptote, and then it goes from -3 to the 3 in terms of x's, and then it jumps over and goes from 3 to infinity. The range is a little tricky. Remember, we always start at the bottom. It comes up from the bottom and it goes as far as a y value, because range is your y's. It goes up as far as y equals 0, and in fact, remember, it touches at that point. It does touch at that point. Because it touches, I'm going to have a bracket. Now nothing occurs between y equals 0 after you leave 0 all the way up to 2. It's just blank. No part of our function occurs here. But if we jump over that horizontal asymptote, we will see the function again. So from 2 to +infinity would be the second part of the answer for D.